Hello, can you hear me? Hello. What do you mean by external exam? For this course? For the NPTEL course? No, I don't have any papers. Hello. Hello. I'm not sure what's happening. Hello. Can you hear me now?
Yes, sir. Yes, sir.
Okay, maybe there's something wrong with my earphones. Is it clear? Is my voice clear to you?
Yes, sir. Now it is audible.
Okay. I don't have any papers, Venkata. I don't have any
Means
question.
I am not asking you the paper patterns, sir. Actually, total 50 bits will be there.
Hmm.
Out of that 50 bits, from each unit, how many we can get? Means total we will have 12 assignments. Means 12 weeks.
Okay.
In that format, I am asking because actually they had given only about 8085 in the assignments. That is in the pattern, but they had also explained about 8086.
Okay, for exam, have they given any syllabus?
Syllabus means in the beginning of the course they had given the total contents of the 12 weeks.
But not for exam, right? For exam, have they given any separate syllabus?
No,
Then I
but now we
think
are getting the bits on 8086 also, no?
yes. But I'm
But
not sure.
they
It
gave only
depends. It depends on who is setting the paper. If they want to set
okay.
questions on 8086, then they can set. But many people don't want to set it, so they might not include questions. But from your end, you will have to study.
Okay.
Mostly, I don't think they will ask, but I can't give any guarantee because it depends
Okay.
on who is setting the paper. Uh, if they want to ask, they
Okay.
can ask. Unless somewhere they have told you that it won't be asked, then you can ignore. But they haven't said like that anywhere, right?
Yes, actually, I asked you that question because based upon the syllabus, we don't have 8086.
Okay, where have they given you a syllabus for the exam?
Yes, in the 12 weeks they had given no. Initial of the course beginning, they given the total 12 weeks contents. In the
But
first week, we'll have so and so like that.
mm, okay, but they
They
have taught you
recall
eight
that
zero.
one.
They have taught you 8086, right? So they might ask this question. It's better to ask in the discussion forum.
But they are not giving any type of reply.
Are they not replying?
Yes.
That is the only way I also have to contact them. I don't have direct contact with any of the course members.
Okay, okay, sir.
So even if I ask, they will. You had asked previously some doubt, right? So I asked the PMRF coordinators, and they
Yes.
told me to tell you guys to ask on the discussion forum. So they
But they are
won't.
not giving any type of reply in that forum.
Uh, there's nothing I can do about that
Okay.
because they haven't given contact information to me also.
Okay, sir.
It is better to study, but from in my opinion, I don't think they will ask 8086. But I can't give you any guarantees.
Okay, sir.
Okay. Any other question?
Nothing, sir. Regarding the exam pattern only, because totally we will have 50. So in that
Yes.
50, we'll get either from that. Is there any chance to ask that one?
They might ask because they have taught it, right?
Yes, they gave
So
the brief idea regarding about that 8086 also.
yeah, but since 8085 they covered a lot, they'll mostly ask 8085. But if they ask one or
Okay.
two questions from 8086, then I can't. I don't know. They might ask.
Okay, okay, sir. Thank you.
Some small things they might ask. They might not ask you to write a program in for 8086, but they might ask
Okay.
you about some resistor or at least the main architecture. They might ask.
Okay. Minimum
At
mode,
least
max
to
and
me,
mode.
they haven't told any particular syllabus. So if I tell you that they won't ask and then they ask the question, then
Yes.
yeah, I can't take any responsibility. In my opinion, they won't ask. I can't give you any guarantee.
Okay, okay, sir.
Okay, let's go to the questions now. The stack pointer always points to the top of the stack, bottom of the stack, middle of the stack, none of the above. What do you think? The top of the stack. Okay. So stack is nothing but a location in your memory that's kind of reserved for only stack operations. So the programmer himself will reserve this part as stack, or it might depend on the device. Maybe some devices have particular addresses that are only used for stack, but in a stack what you do is you give some location as the stack pointer initially, and let's say these are ordered like this 0 1 2 3 and so on. Maybe this is 1000 and this is 1001. So initially stack pointer is set to some address, and whenever you perform operations, suppose you store something onto the stack. Suppose you want to store 0 1 2 3 and you push it onto the stack. 0 1 will get stored here, 2 3 will get stored here, and the stack pointer will get updated to this address. So in this sense, the data is getting stored one on top of the other, and the stack is always pointing to the top of the stack, and this will be called the bottom of your stack. This is more of like a convention that we use. At the end of the day, if they had called the bottom as the top and the top as the bottom, they could call it that, but this makes sense logically, so they're calling it the top in this way. Okay, so the stack pointer always points to the top of the stack. Right, what happens when the below instruction encountered by 8085 microprocessor? The instruction is CNC 4001H. What will happen? The four options are: call the subroutine located at 4001H if carry flag is set. Option B is call the subroutine located at 4001H if carry flag is not set. Option C, call the subroutine located at 4001H if parity flag is set, and call the subroutine located at 4001H if parity flag is not set. So this type of question, if you don't remember what the instruction CNC means, then you could kind of make a guess. If you look at all four options, they are saying it's a call instruction. So you could think that the C that is there stands for call. And then in the options, the flag that they're talking about, they're also kind of giving you a condition, right? The subroutine is called if some condition is met, so it's a conditional call operation. So when what is the condition? It's either something to do with the parity flag or the carry flag. But if it was parity flag, you would have something like a P in the instruction. And since there you have something related to a carry flag, then that's why there's this letter C, this third letter. So that's related to the carry flag. So it's a call when something with regards to the carry flag, and CC, if you directly give that instruction, then it will call subroutine if the carry flag is set. So NC you could think of like not of carry. So you had AND gates and not of AND gate would be called a NAND gate, right? And an OR gate, a not of OR gate would be an OR gate. Similarly, if they give C N C, that could simply mean that when the carry flag is not set, then you call the subroutine. So in this way, you can kind of guess if you don't know the instruction, but if you kind of remember the instruction, common instructions, you can remember CNC, CC, RC, and RNC. These four are common, so they are given as examples. If you remember those, that's fine. Otherwise, you could kind of make a guess that way. So it's call the subroutine given in this address 4001H if carry flag is not set. Option B. I have given the option at the bottom of the page here in for each of the questions. Alright. Which of the following instructions control the interrupt enable flip flop? So 4 options are given: trap, EI, HLT, CPO. Why do you think it's C? They're not asking which
in
of
that
the
interrupt enable, we have two variables, EI and DI. So EA is nothing but enable input.
Yeah, that's option B, no?
Yes, option B.
Yeah.
Interrupt enable has two parts. One is called as EI and the other one is called as DI.
Yeah, you typed
Where EA
option
is nothing
C,
but-
that's why I asked. Okay, there are two instructions that can control your interrupt enable. EI, it will enable the interrupt, and DI will disable the interrupt. But these interrupt enable is only for maskable interrupts. So non-maskable interrupts, they won't care about your IE or the interrupt enable flip flop. So the correct answer is EI. Okay. Which of the following instructions is equivalent to call 0028H?
Option B.
Yes. RST 5. So
Five into 8.
there are 7
14.
of these.
RST 5 means 5 into 8, that is nothing but 40. If we convert the hexadecimal to a decimal value, it is also equals to 40.
Yeah, that's correct. So 28H is 40 because hexadecimal, the base is 16. So 28 is 16 into 2 plus 1 into 8. It's 32 plus 8. It's 40. So you starting from 000H, these instructions are stored. So RST 0 will be 000, and the next instruction will be shifted by 8 in hexadecimal. So 10 is 16 in hexadecimal, that is 8 plus 8. Then 16 plus 8 is 24, that will be 18. So in that way, from RST 0 to 7, you can find the address. Okay. With respect to an 8085 microprocessor, match column X with column Y. So different interrupts are given, and different properties of those interrupts are given: maskable, non-maskable, software, and non-vectored. You have to match those with the interrupts that they give. This also you will have to remember which are the maskable and which are uh, non-vectored and vectored. So here is a convenient table that they have given, from which you can see that INTR is maskable but it is not vectored. So x1 is INTR, column x, index 1. That's how they have named it in the options. And column y followed by index. Uh, so x1 could have been, since it's maskable, it could be y2. Or since it's non-vectored, it could be y4. So both these are possible. But x1 is a hardware interrupt, so it's not y3, and it's also a maskable, so it's not non-maskable. So y1 is also not a correct matching for x1. So it should be either option A or B. See, in these types of questions, sometimes you might forget some of the interrupts. So you might not remember what each of these interrupts are, but if you remember two or three of them, then by process of elimination, you could guess the correct answer. But if they ask you to write it down yourself instead of giving options, then you will have to remember for each of the interrupts. Out of these two options, now we'll check the next one, x2. So x2 RST 5.5 is, that's also maskable, and it is vectored. So the instruction routine is not instruction, interrupt service routine is hard coded. The location is hard coded in the processor, so it's vectored. But there's no option in column y that says it's vectored, so it should be maskable. So x2 should go to y2. Therefore, the correct answer is option B. So in this type of question, if they have given you options, then you can do process of elimination. In that way, even if you don't know the right matching for one of the interrupts, you will still be fine. But if they ask you a different type of question, just where you have to write it down without options, then you will have to know all these things. Okay. How many T states are required by the 8085 microprocessor to execute CNC instruction? This was given in the lecture. CNC call instructions will take 18 T states. So if you are interested in how these T states are consumed, like which of the operations are being performed, then you can just search it yourself. So for each of the instructions, you'll be able to find which operation is actually taking how many states. Like fetching the instruction will take 4 states, right? So all that you can look it up. Okay. How long must INTR interrupt remain high to be sensed by 8085 processor? So like it was told in the lecture, the INTR interrupt must be held until the instruction is executed, because only in the last but one cycle of the instruction will the interrupt be checked. So the instruction which takes the highest number of clock cycles is the call instruction, like we saw in the previous question, and it takes 18 states. So it will start checking in the 17th clock cycle. So at least 17 clock cycles, this INTR must be high. So it's option D, 17.5 clock cycles. Okay. Which of the following statements is true for the given 8085 program? One minute. So, um, first things first, what is EI? It will enable the interrupt. We had seen this in a previous question. Which was it? Here, which of the following instructions control the interrupt enable flip flop? So, EI will enable the interrupt, and then MVI A comma 2AH. It will move the immediate data 2A to the accumulator. So the contents of the accumulator are now 2A in hexadecimal, which is nothing but 0010 in binary. This is the content of the accumulator. Then the last instruction is SIM, and SIM is used to manipulate the masks based on the contents of the accumulator. So here's the SIM, how it will interpret the contents of the accumulator. So we are concerned with only the masks for now. So we don't care about the serial data. So 7, 6 and 5 we don't need to care. Anyway, sixth bit is not enabled. You can see that 6 is bit 6 is 0. So serial data transfer is not enabled. So it can't be option D, serial transmission. That's not enabled. Okay. Then you have to check bit number 3, MSE, because if that bit is not set to 1, then your mask won't be applied. So you have to check this bit. This is MSE. Since it is 1, that means the mask is actually being applied. Then you have to check which of the masks are being applied. So this is for 5.5, this bit is for 6.5, and this bit is for 7.5. So if it is 0, that means that that interrupt is available and it's not masked. If that corresponding bit is set to 1, that means that corresponding interrupt is masked and you can't actually affect that interrupt. So here you can see that only for 6.5 the bit is set to high. So RST 6.5 interrupt is masked. The answer is option B. Okay. Which of the following is not a valid 8085 instruction? All are pop instructions. A is valid. So PSW is the accumulator and the flag combined, right? I forgot the full form of it, but it's the accumulator and the flag contents combined. So you can pop that together to the stack, and whenever you do a pop operation, you have to pop a pair of registers or a pair of bytes. So when you're popping, you can pop B, because whenever you say pop B, it will automatically understand it to be popping to the register pair BC. You can also give pop D. That means the stack contents are popped to the register pair DE. But you can't do pop C, because if you say C, then it doesn't understand what register pair it has to pop the contents to. So and there's no, the register pair CD is not valid in 8085. Can only have B, C, or D, or HL. That's why pop C doesn't make any sense for the pop instruction. So uh, option C is the correct answer. Pop C is not a valid instruction in 8085. Maybe this is valid in some other microprocessor. It could be, depends on the microprocessor. In 8085, it's not valid. Okay, with respect to 8085, match column X with column Y. They are given triggering levels and different RST interrupts: 5.5, 6, 7.5, and 4.5. And one more is software. We think it's C. So 7.5 is positive edge triggered. So X3 must be Y1, right? And 5.5 is level triggered. I think, or is it? Yeah. So it should be X1, Y2. So you can see X1, Y2, X3, Y1 is only in option C. So option C is the right answer. So again, like the previous question, you might not remember the exact matching for all of the options, but since options are given, you can just eliminate those that are wrong. And then you will be left with one option. So here you can see 7.5 is positive edge triggered, 6.5 and 5.5 are level sensitive. So just from that information, we can say that it is option C. Okay. Yeah, Dr. Vijay Kumar.
Yeah, RST 4.5 is not there actually in 8085.
RST 4.5 is nothing but called as trap. It is a trap value.
Okay.
Is it? Okay. Yeah, they're given for 5.5, 6.5, and 7.5.
Sir, excuse me.
Yeah.
Actually, in the lecture class, they told us that trap is nothing but RST 4.5.
Okay.
So based upon that one, we can match that one. Where trap is both level and adjacent edge.
Ah.
So it is correct.
Yeah. So okay, if that is the case, then it's fine. I also don't remember exactly all the pins. Only some of them.
Yes, we have 5.5, 6.5, 7.5 and trap.
Yeah.
Actually, the trap can also be renamed as reset 4.5.
Okay.
Yes, where that trap is nothing but both edge and level triggered. Based upon that one, that option is correct.
Okay. There's a restart I think, not reset.
No, they restart only.
Yeah, they restart.
Okay, restart.
Restart. That trap is decided based on the address actually. The 4.5 into 8 gives you that ISR address, starting address.
Yeah.
That is why he is telling that it is equal to trap.
Okay.
But there is no hardware pin like RST 4.5.
Okay.
Only trap pin, the hardware pin is there.
All right. Then option C is fine. Okay, which group of instructions do not affect the flags?
Data transfer.
Yeah, data transfer operations don't affect the flags. Nothing is changing as such when you transfer data from one place to another. So there's no sign or carry, auxiliary carry. So flags are not affected by data transfer operations. What is the size of instruction queue present in 8086 microprocessor?
6 bytes.
Yeah, 6 bytes are prefetched is what you would use in my field. You would say those things, those instructions were prefetched. Yeah, they are also calling it prefetching. Okay. So prefetching means that before sometimes the resources will be free. At those times, you might do something that you are going that you anticipate will happen anyway. So the instructions might have to be fetched anyway when you are executing a program. So if your resources are free, you will do that earlier. So for that, you will use this queue. You can have up to 6 bytes of instructions. Okay. In 8086 microprocessor, which of the following resistors can be combined together to use as an accumulator resistor?
AL and AH.
Yeah. So even if you don't know these things, you can kind of do guesswork. A lot of the times, you might not know. But at least if you remember 8085, you know that accumulator will be A. And general purpose resistors will be named B, C, D, E, and so on. So when you see accumulator, you might think that it's AL and AH. But you should know. In case you don't know, you can do this type of guesswork. But you can't always do this. Sometimes uh, you guess something and it might be different. Right. Which of the following is performed by execution unit in 8086? Instruction execution, fetching instruction from memory, fetching instruction. Okay, that option is
Instruction
repeated
execution.
twice. Yeah, instruction execution. So again, even if you don't know what the execution unit is, you could at least make a guess out of at least these options given here. It's some type of execution, so it could be instruction execution. So in gate exam, sometimes you'll have to do this. You might not know exactly because there is a lot of things that you need to remember, and you can't remember everything. So sometimes if you forget something, you can do guesswork, but it only works when there are options to check. If there are no options and you're writing the course exam, then you will have to know uh, properly what everything is. Okay, 8086 is a
16 bit.
16-bit microprocessor. That was the first 16-bit microprocessor. So 8085 was 5-bit. So this 16-bit and 8-bit, you can understand it as kind of the operations that it does. It does it with 16-bit data or 8-bit data at a time. You can think of it that way. It's not exactly the same because some instructions might let you do 16-bit operations even if you have an 8-bit processor. For example, 8085 allows you to think of register pairs, right? You can work with register pairs, so that will be 16-bit data. But you could think of an 8-bit microprocessor as working with 8 bits at a time, and 16-bit microprocessor as working with 16 bits at a time. All right. We reached the end of the lecture pretty fast. So I don't have any additional questions prepared. I've asked for an extra session next week. I'm not sure if it will be held. If it's going to be there, then they will announce it in the course page. So next session, I plan to simply pick a few problems from each of the topics and solve them. And if you have any doubts in those topics, you can ask. I plan to take a gate paper maybe and pick out the problems from few of the recent gate papers and just to give you an idea of how it will be. But other than that, that's it, guys. So we have completed the course, at least from my end. Does anyone have any questions? I'm not sure if there will be a session next week, so it's best to ask your questions now. And if you have no questions, you can leave. I will go through all these things again because unfortunately, through no will of my own, I have to drag this on for as long as possible. So they have given us requirements for conducting TA classes for 2 hours, whether there is enough content for 2 hours or not. So I'll go through all these things again. If you want to stay, you can stay if you miss something, or you can leave. Okay, I'll go through these questions one by one. Stack pointer always points to the options are the top of the stack, the bottom of the stack, the middle of the stack, and nothing. So the correct answer is the top of the stack. So you start out at the bottom and you grow the stack by heaping data or instructions or whatever content it is on top of each other. You can think of it like a stack in general in English means a haystack, you could think of. So things piled on top of each other. So that's literally how it is named. and your stack pointer will always point to the top position of your stack. Okay. What happens when the below instruction is encountered by 8085 microprocessor CNC 4001H? Like I said earlier, if you don't know what instruction that is, you could do some intelligent guesswork. If you know it, then fine. It's best to know it. But in case you don't know it, you check the options. You see that all options are saying it's a call instruction. So you could think, say, one of the C's in here, the C out of C and C, the first C, that's for call. And then you see that all the options are conditional call operations. So they're only calling the subroutine if something is happening with a certain flag. So two of the options are to do with carry flag and two of the options are to do with parity flag. And if parity flag was being checked, then you would have a P in this instruction somewhere. At least logically you would think that's the case. And if there's a carry flag, then you would have a C. So you could say C and C is the call if something happens with the carry. And if directly you had CC, call if carry is set, that would be CC. Since you have an NC, you could think of gates where you have an AND gate, and an AND gate would just be the complement of the AND gate. So you could think of NC whenever you see an N as a NOT of the carry. So your call will be executed if the carry flag is not set. So in this way you can do guesswork if you don't know the instruction. But common instructions like CNC and CC and RC, you will have to learn them if you plan to learn 8085 properly. This is like in any other language, say Python or C program. You would know what a while loop or a do while loop, a for loop is, and what arguments you have to give, what are the conditions, how do you carry out iterations. You would need to know that. This thing is similar to that, except in assembly language. Okay, Q3. Which of the following instructions control the interrupt enable flip flop? So all these are interrupts. At least from what I know, trap, EI, and HLT are interrupts. CPU, I'm not sure. But they are not asking which of them are interrupts. They are asking which of them are instructions to control the interrupt flag. Those are EI and DI. EI will enable the interrupt flag and DI will disable the interrupt flag. And this will only enable and disable those flags which are okay. The question we are looking at now is which of the following instructions control the interrupt enable flip flop. You have trap, EI, HLT, and CPO. And from class we know that EI and DI are the instructions used to control interrupt enable flag. EI means enable interrupt, and DI means disable the interrupt. And this enable and disable are only done for maskable flags. So if the flag is not maskable, then it doesn't care about the EI and DI. Okay, so the correct answer is EI. Question 4. Which of the following instructions is equivalent to call 0028H? So restart instructions, there are 4, 4.5, 5, 5.5 and 6. And the trick to remember is that the restart instructions with integer values or whole number values are restart 0, 1, 2, 3 up to 7. So they are equivalent to calling the address for restart 0, it's 000H, and for the next consecutive RST instruction you add 8 in hexadecimal. So RST0 is this. For RST1, you add 8 in hexadecimal, you will get 0008H. RST2, you add 8 to this again. So 8 plus 8 is 16, which will be 0010 in hexadecimal. So on. 0010 plus 8 is 0018. 0018 plus 8 is 0032, which is 0020. Next one is 38, 0028. Next is 46. Sorry. Next one is 28 is 40. Next one is 48, which is 0030. The next one is 56, which is 0038. So in this way you can remember the address, and from that you can see that call 0028H is equivalent to restart 5. Okay. With respect to an 8085 microprocessor, match columns X with column Y. You have interrupts in column X and their properties in column Y. So the first interrupt is INTR, and the possible answers are INTR is maskable and it is non-vectored, so it could be x1y2 or x1y4. So it could be option A or option B. And then RST 5.5 is maskable and vectored. There's no vectored in column Y, so maskable, and it's not a software interrupt, it's a hardware interrupt. So RST 5.5 maskable, that is x2 y2 is correct, so that's only present in option B. That's why option B is the correct answer. So trap, like student said earlier, you can consider it equivalent to restart 4.5 with okay. Again, that is trap is on non-maskable, so takes 3 y1, and RST1 is software. RST0 to 7 that we saw in the previous question, they're all software interrupts. Hardware interrupts means that there's a physical pin that is present to which you can give a pulse to say that there's an interrupt. So software interrupts don't have a dedicated pin to them through which you can tell the processor to stop what it's doing. Okay, how many T states are required by the 8085 microprocessor to execute CNC instruction? Call instructions have the longest number of T states, and that is 18. So even a normal call will take 18 T states. CNC is a call instruction, so it will also take 18 T states. How long must INTR interrupt remain high to be sensed by 8085 processor? So INTR must remain high so that even the longest instruction will be able to detect the interrupt. So when an instruction is being fetched and executed, it will only check for interrupt signals in the last but one cycle. So since the call instruction has 18 cycles, it should wait till 17 cycles. So 17.5 T states is the right answer. Q8. Which of the following statements is true for the given 8085 program? So EI will enable the interrupt, enable all the maskable interrupts, and then MVI A,2AH, it will move the immediate data 2AH to the accumulator. So the accumulator content is 2A, which is 0010 1010, and then the last instruction is SIM, which is used to manipulate the uh, masks for the interrupts and also to give serial data. So it will do this based on the contents of the accumulator. The contents of the accumulator are this, and we see that bit number 6 is set to 0, so it will ignore bit number 7, so it's not giving out serial data, so serial transmission is not enabled. And MAC, that is bit number 3, is set to 1. So since it's set to 1, the mask is actually enabled. So you can mask the three restart interrupts, 5.5, 6.5 and 7.5. Out of them, whichever is 1, that will be masked, and whichever is not 1, that is whichever is 0, that will be available for interruption. So since we can see that only 6.5 is set to 1, so only restart 6.5 interrupt is masked, so it's option B. Okay, which of the following is not a valid 8085 instruction? Pop PSW, Pop B, Pop C and Pop D. So if you remember what a pop instruction is, a pop instruction will pop the contents of the stack onto a pair of registers. So it will pop it onto a pair of registers, so the location to which you are popping it to should specify a register pair. So PSW is a pair, and when you say pop B, it will consider BC as a pair, and when you say pop D, it will consider DE as a pair. But pop C, there's no pair that starts with C. So CE is not a pair, CD is not a pair, BC is a pair, but to point to BC, you will have to specify B instead of C. So pop C is not a valid instruction in 8085. Next, with respect to 8085, match column X and with column Y. So they have given you in column X the interrupts, and column Y they're triggering, edge or level triggered, and one option is which of these is a software interrupt. So 7.5 is positive edge triggered, so X3 should go to Y1, which happens in both option B and C. And RST 5.5 is level triggered, so X1 should go to Y2, which happens only in option C, so option C is the right answer. And RST6 is a software interrupt, so X2 should go to Y4, that's satisfied here. And the remaining one is RST 4.5, which is apparently equivalent to trap interrupt, which is both edge and level triggered, so X4 goes to Y3. So the right answer is option C. Which group of instructions do not affect the flags? Data transfer instructions do not affect flags. Arithmetic and logical operations both affect flag content. What is the size of instruction queue present in 8086 microprocessor? 8086 gives you 6 bytes to store instructions. So you can prefetch 6 bytes of instructions and store them. So the queue length is 6. In 8086 microprocessor, which of the following registers can be combined together to use as an accumulator register? A, AL and AH. If you don't remember this, then you could think of an 8085 microprocessor where the accumulator is named as A and the general purpose registers are named as B, C, and D. So you would guess, and you would correctly guess, that the accumulator can be formed using registers that start with A. So if you don't know the correct answer already, then you might guess in that way. Alright. Which of the following is performed by the execution unit in 8086? Option A, instruction execution. Option B and C are repeated fetching instruction from memory, and option D writes data to memory. Here again, even if you don't know what an execution unit does, from the name itself, mostly names are given intuitively, and they kind of tell you what something does or something is. That's how it goes in science and engineering. The names are kept as simple as possible, and most of the times they literally mean what they say. So an execution unit will do some type of execution. What can you execute? In a microprocessor, you execute instructions. So even if you don't know what an execution unit does, you might guess, and you would be correct in guessing that option A is the right answer. Instruction execution. The final question is 8086 is a dash bit microprocessor. It's 8 bit, 16, 32 bit, and 64 bit. So 8086 is a 16 bit microprocessor, the first 16 bit microprocessor ever made by Intel. 8085 is 8 bit and 8086 is a 16 bit. The way to think of it is, if the microprocessor can do 16 bit operations at a time, it can work with 16 bits, then it's a 16 bit microprocessor. These days, you can see 32 bit systems and 64 bit systems built. So, those things will work with 64 bits taken at a time or 32 bits taken at a time. They will consider that entire thing as one word. They'll work with words. So, you can think of it that way. Alright, that's the official final problem solving session for the course. I'll try to hold one more session next week where I'll kind of summarize everything that we have covered till now, but uh, officially this is the end. Thank you for joining me for my problem solving sessions, and I hope that you learned something from this. Alright guys, I'll end the session now. So I'll just stay here for 5 or 10 minutes to see if anybody else joins and if they have a doubt. Otherwise, after 5-10 minutes, I'll also leave. Thank you for joining. Bye bye.